Hello all. Welcome to this video series on glaciers and glacial landforms. We're going to start off with an introduction of glaciers. Then we're going to move to some of the landforms that they create. Then we will tour Niagara Falls, some of the waterfalls in the Finger Lakes region of New York State, and wrap up at a Finger Lake itself. So a glacier is a mass of ice that has a footprint on land, has to have a footprint on land, and it has to be moving. This movement causes erosion and creates landscape forms. Most of the glaciers are in polar regions because of the climate. Other glaciers exist on mountains. All of the world's continents, though, have glaciers in some way, shape, or form. This map here relates glaciers and ice caps, which are white, to climate. And you can see even in equatorial regions, there are glaciers. They just happen to be high above sea level, where the air is cooler. Now, glaciers move, as we mentioned. They have to move under their own pressure, and they flow downhill. Solids flow too. They're called amorphous solids. So glacial ice is amorphous. It flows, and as it flows, it carves out valleys through abrasion, plucks boulders, deposits, and then in the lower valleys, as those glaciers melt, they create rivers, outwash plains, and lakes. Two main types of glaciers: the continental, which we call ice sheets, and alpine, which are mountain glaciers. Greenland and Antarctica are our current ice sheets. These ice sheets were a lot larger about 15,000 years ago, which was part of the Wisconsin glacial period. We are still in an ice age. Most people think that we're not in an ice age, but anytime there are ice caps, we are in an ice age. We're just in an interglacial period of an ice age. During the glacial period, the glaciers were far larger and encroached down much of North America and Europe. As they retreated, sea levels rose, and currently we have two ice sheets, Greenland and Antarctica. There's satellite imagery of Greenland and Antarctica. If these melt, sea level rises accordingly. Now, the North Pole, which is covered with an ice cap, that ice is already in the water, so the sea won't rise if the North Pole were to melt. Of course, it would change ocean currents and affect world climate, but the rise and fall of sea level, the ice has to be on land for that to impact sea level. Now, our mountain glaciers or alpine glaciers have three parts: the cirque, which is the top, and you can see the image of the cirque; the valley, which carves out that valley. You can see the cirque image has a valley starting. And then the floor, the valley floor, where the glacier reaches, is called the Piedmont portion of that glacier. This image nicely shows the cirque, the valley, and the Piedmont. Now, as this glacier moves through that valley, it plucks rock, pulls it right out, and then it drags that rock in an abrasive method. So the two main types of glacial erosion are plucking and abrasion. You can see plucking in New Zealand there, in one of the alpine glaciers, pulling that boulder out, and then striations caused by abrasion in Alaska. These glaciers carve out valleys. When the glaciers retreated, these valleys became either Finger Lakes, which filled with water, or river valleys, which widened because of erosion. But glacial valleys are steep, A lot of ski slopes are on the sides of glacial valleys and not true mountains. And at the head of that valley, usually you have a bowl-shaped cirque where the glacier originated. There's a cirque on the peak of a glacial valley in this image. Artets and horns are jagged glacial landforms at the peaks of these alpine mountaintops. Then you have your cirque and your valley glacier. The horns, the most famous ones that I know of are Grand Tetons National Park. Fjords are estuaries. As sea level rose, the bottom part of a glacial valley often filled, causing very deep estuaries that are called fjords, which is a Scandinavian term. Drift is the sediment that is transported by glacials or glacial melt. Till is unsorted. So like a bulldozer pushing and stopping, that's till. If it's stratified, which means sorted, the melt water pushes it away, and then as the water slows, the big ones are deposited first, so they're sorted by size, medium, and then smaller, and that's called stratified drift. So sorted, water-based stratified drift versus ice-pushed, then random deposited till, glacial till, and glacial stratified drift. Huge boulders that seemingly don't belong, that were plucked from walls of mountains or valleys, are called erratics. Now, moraine is the collective term for any depositional environment by a glacier. Terminal is the ending, lateral is the side. So the prefix terminal, lateral, end, ground just refer to the location, and then moraine itself is the glacial deposit. So terminal moraine, recessional moraine, lateral moraine are all different depositional areas as glaciers advance and retreat. Outwash plains occur at the terminal end of your glacier, that Piedmont end, and as it melts, it washes away, causing plains. This soil tends to, well, it's not deep, rich soil because a lot of it's washed off. It's rather sandy because sand is a larger sediment. It's specialized like potatoes on these outwash plains. Kettle lakes are where huge chunks of ice are buried, and then they melt, and it forms deep meltwater lakes. Drumlins, and they occur in fields, are elongated, almost cigar-shaped hills that are caused by glacial movement. Eskers and kames are ridges and hills formed by glacial movement and deposition. Now, like I mentioned, we're in the Ice Age, but we're in an interglacial. Ice ages are areas where we have ice sheets and mountain glaciers. You can see the glacial period, how much of South America, North America, Europe was covered with glaciers. Of course, these glaciers retreated, causing rapid sea level rise and formation of the Mississippi River, the Black Sea, the Great Lakes, the Finger Lakes, and many glacial landscapes that we'll be looking at. Long Island is a terminal moraine deposited. You have the Great Lakes, the Finger Lakes, which we will tour, the Finger Lakes. The Mississippi, which was a small river, lengthened. Sea levels rose 400 feet during the end of the glacial period. And of course, the Black Sea was formed along with many other landforms. What causes glaciation? Small temperature changes. Remember, the Earth is huge, So a small temperature change in the Earth really is a lot of energy. 4 to 5 degrees Celsius should increase snowfall enough for glaciers to form, or should uh, cause enough melt for glaciers to retreat. So it doesn't take huge temperature swings to cause ice age or interglacial conditions. Now, it's a lot of factors. It's not just humans, but we'll be studying the greenhouse effect later. Uh, Insolation, incoming solaration, reduced solar activity, increased volcanism can block out the sun, shifting of the continents, changing ocean currents. So plate tectonics, solar activity, wobbling in Earth's orbit, many different factors roll into Earth's climate. Very, very complex system. We do play a role in it, though, and would be silly not to recognize that. We mentioned the orbital eccentricity. That is the how flat our orbit is, or how oval our orbit is. Our orbit is actually elliptical. The axial tilt causes seasons. So we have a 23.5-degree axial tilt, but if the tilt changes, that's the obliquity, that would change our climate zones and cause different glacial, interglacial scenarios. And then Earth's wobble in its orbit does affect our climate as well. So we study glaciers, their advance and retreat yearly, and we can trace the changes in glacial movements with the rise in global temperature caused by the Industrial Revolution, the increase of carbon dioxide in the atmosphere. We put all the studies together and we can conclude that our carbon dioxide input is warming the planet, causing glaciers to retreat. Now, our first field trip that we'll be looking at is Niagara Falls, and there's a picture of Niagara Falls. We'll be looking at the Niagara Gorge, how it formed, a little bit of the geology. It's very, very fun and interesting. We have an American Falls, the Canadian Falls. You can see you have this horseshoe falls here, and the upper layer is hard dolomite, and then the lower layer of the rock is shale, which is softer. And what happens is it's retreating, it's changing through erosion, and the lower half erodes slightly faster than the upper half, creating that cascading effect. And then the upper half, a chunk of rock will fall off, and then the lower half will erode. So the falls retreat, but they remain waterfalls and they don't flatten because of the different hardnesses of the rocks involved. So the strata is perfect for waterfalls in these areas. Not all areas that have glacial influence get waterfalls. You have to have the proper geology for them. We're going to take a trip through the Finger Lakes. The Finger Lakes are glacial valleys that filled with water. You can see they're called Finger Lakes because they're very long and very narrow, kind of like fingers. They did form at the end of the last ice age. The Native American legend states, because the Iroquois were the people of the Finger Lakes region, the Iroquois, very fascinating history, and they believed that that was the creator's handprint. Of course, geology tells us a little bit different. It tells us that the final glaciers at the end of the last ice age, as they retreated, their valleys were carved out and filled with water and became the Fingers Lake region, which are noted for incredible gorges and numerous waterfalls. Now, a waterfall, and we will have top and bottom pictures of waterfalls, the plunge pools, where the water carves out, and you can see some rubble in those fallen rocks. We actually have videos of those fallen rocks being removed. Folks in The tourism industry loved to swim in plunge pools, not necessarily Niagara, way too strong, but in smaller waterfalls. These rocks are removed seasonally after the fish spawn, so you can have safe swimming conditions, but you have to have hard upper rock, less erosion resistant lower rock, and what happens is this gets eroded, this falls, this gets eroded, this falls, and you continue to have a waterfall. I hope that you have enjoyed this brief introduction of glaciers and glacial landscapes, and I hope that you enjoy the tours of Niagara Falls and the Great Lakes region of New York State. Thank you.